Hey everybody, in this video we're going to talk about the cosine rule. So in a previous video we talked about the sine rule and when we can use that. And we looked at that where we had an angle and its opposite side, or maybe a couple of angles and a side, and we could find the other values using the sine rule. But if we notice, based on the information given with these two triangles, we can't use that sine rule. And if you're not familiar with the sine rule, make sure you go back and watch my other video on sine rule, so that way you can make sure that you're familiar with that. So we don't have enough information to use the sine rule, so we've got to come up with something else, another way to find missing angles and missing sides. So what we're going to do is we're going to create the cosine rule. And we're going to do that from a similar triangle like we used when we found the sine rule. We've got ABC, triangle ABC. We're going to drop the altitude of A to side B. We'll call that our height. We'll use H instead of altitude for A because we know opposite side is A there. So then we'll label these sides like we do with our non-right triangles as well. But we're going to do a little different. Now that we've got two right triangles, we're going to label side BD as X and side CD as A minus X. So, excuse me, using these right triangles, we're going to come up with this cosine rule. So let's start with triangle ABD. Using Pythagorean Theorem, we have h squared plus x squared equals c squared. Now our problem with this is we've got two new values introduced into this non-right triangle by creating the right triangles, by dropping that height and making that value x. So we basically have to eliminate those things as we go through this. So we're going to start by just focusing on h, and we're going to move or get h by itself and move x squared to the other side of the equation. Now let's look at triangle AACD, and we're going to do the Pythagorean theorem for that as well. So we've got h squared plus a minus x squared equals b squared. Let's expand out that a minus x squared, and we have all of this equal to b squared. And now, but we already know from above what h squared is, so we can substitute it in down here. So now we've got c squared minus x squared plus a squared minus 2ax plus x squared equals b squared. As we simplify, our x squareds cancel out, and we've got c squared plus a squared minus 2ax plus b squared. Okay, so that gets us so far, but we still have this unknown x value. So what we want to do is we want to still find a way to get rid of that. So we're going to focus again on triangle ABD, and we're going to look at angle B. We're going to use our cosine rule using adjacent over hypotenuse, and we have that equal to x over c. So if we want to get x by itself, so we can substitute back in and get rid of x in our equation below, we need to multiply both sides by c, and we get x equals to c cosine b. Plug that in down here, and we get b squared equals a squared plus c squared minus 2ac cosine b. This thing here is our cosine rule. What this does is this puts everything in terms of the given values or potential given values of our non-right triangle. We don't have this height in there anymore. We don't have that x value in there anymore. All we have are sides A, B, and C, and maybe an angle. So if we were to look at this triangle at the up above on the right, and we relabel it ABC, and we have these opposite sides, 13.2 is going to be C, 8.9 is going to be A, and now 80, we can do cosine B, and we have enough information to solve this thing. So that's if we had the altitude or the height coming from angle A. Now we could have done that from angle B, we could have done that from angle C, and if we did, we would run through the same process and we could get very similar equations, right? So all three of these things are our cosine rule. And if you notice, the sides that we're looking for are opposite of the angle that we have. So here we're looking for B, side B, and we have angle B. Here we would be looking for side A, and we have angle A, or C and C. And notice the rest of the stuff on the right portion of this equation are the sides that were given all the way through. So those match up as well. So it's interesting to see kind of how these values play in the relationships that they have. But this works for the type of triangle on the right, the triangle XYZ. But what about the triangle on the left? How do we take care of this if we've got three sides and no angles? Well, what we can do is we can rearrange our cosine rule and rewrite that so we're looking for an angle, not for a side. So let's just take our first one, a squared plus b squared, a squared equals b squared plus c squared minus 2bc cosine a. So in this situation, we have all of the sides. So we have a, b, c, but we don't have cosine a. We don't have angle a. So if we move negative 2bc cosine a to the left side of the equation, and we move a squared to the right side of the equation, we get a new equation that looks like this, right? So we're trying to get cosine a by itself. Divide both sides by 2bc, and we get cosine a is equal to b squared plus c squared minus a squared divided by 2bc. So the right side of the equation is all side values, lengths of the sides. And again, if we chose the one that started with a squared, if we did this with b squared, we would get a very similar formula, all rearranged and going through that. We're not going to spend the time doing that. And same thing if we started with c squared. We can rearrange that one as well, so we have it in terms of cosine c. And all of these are also considered part of the cosine rule. So even though there's a lot of stuff here, it's really based from one formula or one angle, but you can modify it to fit any of your angles for your non-right triangles. All right, so let's see how these things actually work, solving for these two triangles up above. All right, so what we're going to do, what we're going to solve for, is we're going to try and find all of the missing sides and angles for these two triangles, for the one on the right and the left. Okay. So, starting with the one on the left, we have all three sides. So that means we're going to have to use the purple formulas that we used before. So let's pick an angle. I'm going to pick D. No reason, just picking D. We could have started with E. We could have started with F. So I'm going to plug in the values. So we're going to have, if we're looking for angle D, we're going to have side E and F squared. We're going to add those together. We're going to take away d squared, and then we're going to divide by 2EF. So cosine d is equal to 6.56 squared, that's little e, plus little f, which is 3.63 squared, minus little d, which is 8.28 squared. And we're going to divide that by 2 times e, 6.56, and f, which is 3.63. Now we can do all this in our calculator. We're not going to spend the time and go through step by step for this, but we can start working towards that inverse of cosine to find out what that value of d is. So d is going to equal the inverse of cosine of this whole thing calculated out, which comes out to be approximately negative 0.25927. Now I'm rounding because that's what my calculator showed me. So when we do our inverse of cosine for this, we end up getting d equal to 105 degrees. Now I'm using three significant figures here. There's some decimals on there, but I'm just rounding to three significant figures just to make it a little bit easier. Now we have to find another angle. So at this point, we could use the sine rule, we could use the cosine rule, but I like to try and use as much of the given information as possible, as long as possible as I'm working through these things. Because if I made an error in my calculation for d, it will continue to carry through if I continue to use that angle d in the sine rule. So instead, I'm going to do angle E. I'm going to look at angle E. So we've got 3.63 squared plus, let's see, that's going to be, that's F. So then we need to have D, which is 8.28 squared, minus E, which is 6.56 squared, divided by D times F, so 3.63 and 8.28. Similarly, we're going to find the inverse of cosine for E, which is 0.643818. Again, rounding a little bit. And when I hit go on that, E equals 49.9 degrees. Again, rounded for 3 significant figures. So we can find F by taking these values away from 180, the sum of these two angles that we just found, and we get F equaling 25.1 degrees. So now we have just found the 3 angles for this triangle. Easy peasy. A lot of calculations, a lot of numbers, but fairly straightforward now that you've got the formula. So what about this one on the right? So we have two sides, we have 80 degrees. So let's start by looking for side x. So x squared is going to equal 13.2 squared, so that's our z squared, plus 8.9 squared, minus 2 times those values, 2 times 13.2 and 8.9, times cosine of 80 degrees, right? Just following the formula from before. Punch all that into our calculator, crunch, crunch, crunch. X squared equals 212.65. We don't want to know what x squared is, we want to know what x is, so we square root both sides, and x is equal to 14.6. Again, rounded. Okay, so now we want to we've got all 3 sides, so now we need to find an angle. So we could use the cosine rule, but the cosine rule is going to have to use this 14.6. Right? The only way to find an angle from that is to use all 3 sides. The sine rule also uses an angle and this 14.6 and then an unknown angle. So either way, you're going to have to use this 14.6 value again. So what I'm going to do is I'm going to use the sine rule just because it's a little bit easier, a little bit quicker to do. So I'm going to say sine of 80 over 14.6 is equal to, let's do y. Sine of y over 8.9. Now I want to get sine of y by itself, so I'm going to multiply both sides by 8.9. So sine of y is equal to 8.9 over 14.6 times sine of 80. Again, do our inverse of sine and calculate that whole value, and we get y is equal to 37.2 degrees. Now in previous videos, we always talked about, in the previous sine rule video, we always talked about checking for ambiguous cases, ambiguous angles. So let's do that real quick just to make sure. So we can take 180 minus 37.2, and that equals 142.8. So now if we take that and add it to the given angle that we have over 180 degrees. So that means there are no ambiguous angles here. Everything is good as we're solving it. So we can keep 37.2. We don't have to do any other adjustments. Now the last thing is to find angle Z. And again, that's like finding angle F. In the last one, we just take 180 minus the sum of the 2 angles that we have. And Z is equal to 62.8. And we've now found the 3 missing pieces of this triangle as well, using a combination of cosine and sine rule. So hopefully that's helpful for reviewing how we find the cosine rule, how we can use the cosine rule, how we can use it with the sine rule, and finding missing values. So it's all about kind of assessing what information you have to determine which rule you should use, sine or cosine rule. So I hope that helps, and I will talk to you in the next video.